Hello and welcome to today's T&D World webinar titled Cable Pulling 101 in the Age of Strategic Undergrounding, Complex Urban Undergrounding, and AI. And this is sponsored by PDi² in partnership with Champion Fiberglass. I'm Jeff Postlewaite, Managing Editor of T&D World with Endeavor Business Media. So just to begin with, let me explain how you can participate in the session today. If you have any technical difficulties during the session, you can use the questions window. Just type in your problem and hit submit. Our technical experts will help you out. Just as a curative, we recommend that you disable any pop-up blocking software or extensions because these can sometimes cause the webinar player to have some problems. And we do definitely want to have your questions during today's event. That's what makes these so fun. We'll answer as many of those questions as we can during the Q&A session to follow the main presentation, but you can submit your questions just as soon as they pop into your mind, including right now. So just type in your questions into the question window on the side of your screen and hit submit. It's always a good idea to refer a friend or a colleague to today's discussion if you think they would get something out of it. You could share it on social media. And to access event resources, just click the icons on the left-hand rail on the screen. To resize your windows for a better view, you can click on the upper right-hand corner to enlarge your screen. And please be aware that today's session is being recorded and will be available on our T&D World website within the next 24 hours, and we will hit you up with an email when that archive is available. So with all that said, I want to hand it over to Mike Beehler, who will introduce our panelists, and Mike will sort of drive the bus as the moderator continues through our event.
Thank you very much, Jeff. I appreciate it. Welcome to everybody. This is the last webinar of the year from the Power Delivery Intelligence Initiative, and we're excited to be with Champion Fiberglass and Matt Fredericks to talk about something that's really cool, and the timing is outstanding. So I'll just tell you briefly that the Power Delivery Intelligence Initiative is a group of contractors and consultants and fabricators and cable manufacturers and equipment manufacturers that advocate for underground. We want to be a resource for planners and engineers, and today, even data scientists, to help evaluate the total cost of ownership of overhead versus underground electric distribution and transmission over the life of the asset. So what's it really cost to have an overhead versus an underground system over the life of the asset? So that's what we do at PDi², and Champion Fiberglass has been one of our members for a long time, and we appreciate that. Today with us is Matt Fredericks, and he's a vice president at Champion. Matt, say a brief hello to us, if you would, please.
Thanks, Mike. Hey, guys, this is Matt Fredericks. I'm the vice president of sales and marketing at Champion Fiberglass. Super excited to be here today. Mike and I will keep this conversational. If you have any questions at any time, pop it into the chat box. We will try and answer questions as they come in. We will try and leave a good chunk of time at the end here for questions, as I think this will be a pretty thought-provoking discussion.
I agree. I think it'll be really thought-provoking. And with that, Matt, you told us how it's going to work. So go ahead and take it away. We're going to talk here for a little while, and then we'll take the questions. So Matt Fredericks, take it away.
Sounds good, Mike. Thank you. So today we're going to talk first a little bit about what's happening in the industry, why it relates to undergrounding, talk about cable pulling, and then a few other topics after that. So first we're going to talk about what's really happening with utilities and how it relates to data center growth. So what we're seeing right now is a boom of what's called hyperscale campuses, which are using more than 500 megawatts of electrical demand. What does that translate into? That translates into massive duct banks, high density racks, and a lot of need for both power and fiber optics in these realms. That's due to what's happening with cloud, whether it be Microsoft, Apple, and then AI, or Google, ChatGPT, and tons of other programs that are now utilizing AI. It's a fabulous and great tool to use. I use ChatGPT for email drafts, proofreading, multiple different things. One little tidbit that I'll share, just in case most of you don't know this, one ChatGPT search uses as much power as powering your iPhone from 0 to 100%. So the amount of energy that ChatGPT and other AI programs use is very, very immense. So that translates into electrical load growth. So what
hey,
does
Matt,
that
let
really
me ask
mean?
you a question real quick.
Yeah.
So I look at these duct banks that you're showing in that previous picture, and they're massive.
Yes.
I mean, what about the heat buildup? I'm going to bet that you're going to talk about heat dissipation with fiberglass,
Mhm.
but these are really, really massive duct banks with what, dozens and dozens of ducts. What's going on?
Yeah. Well, this, as you know, Mike, being an electrical engineer, creates a very interesting problem for the project owners and the engineers, as well as the contractors dealing with these large buildings. So you're dealing with cables that are running really hot because they're trying to get the maximum amount of amperage out of the cable to be able to run these data centers as powerfully as possible. So what does that mean? Well, there's a lot of research going into concrete right now. If the duct banks need to be concrete encased, a lot of folks use what's called red dye concrete, which is highly compact concrete that allows the heat to dissipate faster rather than regular concrete slurry, native soil, sand, other things of that nature. That concrete is anywhere from 3 to 5 times more expensive a yard than regular slurry. So it makes things a lot more expensive. So folks are looking at different conduit materials as well as a multitude of other products to try and defray that cost.
Good, interesting.
So
Thank you.
yeah, absolutely. Note on this slide, single AI training runs can consume as much power as small towns. I've seen as much as small countries. So we're starting to see a lot of interesting things happen around power generation. These micro nuke sites. Mike, I think you and I have talked about in the past how in both of our lifetimes, we never thought 3 Mile Island would open again.
It's
But now
amazing,
that's
isn't it?
yeah, that's opening up between, I think, what is it, Microsoft and the Constellation Group, and it's been closed for, gosh, I don't even know how long. So, you kind of look at that and scratch your head and say, okay, what's next? Prior to coming on the presentation today, I mentioned to the folks at TD&W and Mike that I saw that Chevron is opening up their first behind-the-meter power plant out in the Permian with all that excess natural gas to supply power solely to the data centers. It will go directly to those data centers. It's not a power plant that will be necessarily on the grid for use. So pretty wild. So we started talking about this, but why does AI expansion drive undergrounding? Well, part of the reason is we're continuing to become more dependent upon these tools and services that are web-based. And underground systems reduce storm and wildfire disruptions. We hear all about this on the West Coast, Hawaii. Wildfires are becoming a lot more prevalent, as well as tornadoes or really any type of storm. We want to keep that that power underground. It also reduces the total cost of ownership. That's something that we've talked a lot about, and have done quite a bit of research at PDi². Is not only is it more visually appealing not to see elements of the grid overhead, it also is much easier to maintain once it's underground because there's less chances for disruption, whether it be vehicle crashes, weather incidents, what have you. So one other thing that I
for a couple of years. Yeah, we've talked for a couple of years, Matt, just to interject here real quick, that that
Yeah.
resiliency is really important in the industry. Resiliency defined as the ability to withstand a high impact but low probability event, like the things you mentioned, whether it's a wildfire or a tornado or hurricane, Cat 5 hurricane or something like that, massive ice storm. You got to be able to survive those with little or no outage. And when the whole economy of the country is going to ride on a lot of the things that we're putting in the ground today, it makes it all the more important.
Yeah, it does. And we see, a lot of utilities and, private entities investing in underground power. Even folks that would say, okay, my service to my factory or what have you would be perhaps less expensive upfront if I did simple overhead distribution. But in the long term, it's going to cost way less to maintain that and also not have those service disruptions that you may have if your electrical service is overhead. So people are really thinking ahead now, which is fabulous. It just means, far less downtime for everybody, much better reliability. All right, so this is kind of a funny presentation, but I'll explain why I'm putting in, some notes about cable pulling in here. I've been on numerous job sites over this past year, and because the power requirements are getting so large, which means cables are getting larger, duct sizes are getting larger, cable pulling is becoming a lot more complicated, or rather complex, I should say. And cable pulling, in my opinion, is really an art and a science. So I wanted to talk a little bit about the fundamentals of cable pulling because I've seen some installation practices over the past year that I've scratched my head a bit on. So a quick refresher on this, I think, is good, as a lot of what's being installed on these data centers is really what I would consider to be utility grade cable pulling. Not only from the utilities and their contractors who are pulling it in, but then the project owners that are having those same entities pull it all the way to the building. So what should we be thinking about when we're pulling cable? Well, we really need to be thinking about three things. What is the cable weigh? What's the coefficient of friction without lubrication on the duct? And then what's the overall tension? That's what's going to define pull difficulty. Now, with all of that being said, and I'll talk about this as time goes on, there are things that we can do with, or rather a number of things that we can do to reduce all of those things, like lubricant, swivels, all that. But I just want to remind everybody, sidewall pressure limits determine safe routing around bends. Sidewall pressure is a massive thing to be thinking about. I would recommend everybody, use a cable pulling software. There are a number on the market right now. But with the cable weight, cable size, and duct size that folks are using presently, it's so important to do your due diligence ahead of time. Make sure you're thinking about those resources that are available. There's so many technical resources available to us all the time. And if you do the appropriate planning ahead of time, it will reduce the downtime getting these sites up and running.
Matt,
Pulling.
Are you satisfied with the cable pulling programs that are out there in the industry today? Is cable pulling program A equal to B? Or do they satisfy you in the things that you need specifically for fiberglass?
That's okay. That's a really good question, Mike. I mean, the deal is, and I'm sure there's a multitude of engineers on the call right now that fully understand that cable pulling is based off of the Rivenberger formula. It's not, some nonsense that we all pull out of thin air and just divine, or like witch for water, if you will. This is all math. So really, what it comes down to is, how specific is the data in those programs? Different conduit types or styles may have nuanced differences. We know that for our conduit, we tend to have a slightly better coefficient of friction than our competitors. So we are able to supply exact coefficient of friction data points with cables two set of engineers rather than having a more generic formula. But for all intents and purposes, what's on the market right now will do a pretty darn good job of getting you where you need to be. So I guess it comes down to personal preference of what works best for you. So I will say, just want to hit this home on this side. Improper pulling increases risk of insulation defects. A lot of people will talk about, hey, we have this puller that'll pull 12,000 pounds, 15,000 pounds, and the cable made it out the other side. Well, just because a cable made it out the other side doesn't necessarily mean that it wasn't damaged in the process. That's why that pull planning matters so much. So things that we can do to help, and these are just a couple things. It's not comprehensive. This may seem, kind of elementary or odd to people that I'm going to talk about a swivel, but Mike, I'm sure you've probably been on many plant audits. You see how cable is made, and it's in a rifled pattern. Cable, rope, many things like that have a natural lay to them, which means that when they're being pulled, they're rifling out. They have a direction to them, if you will. So the reason why we use swivels is it prevents that rotation from happening when you're pulling it. And that's same with the rope too. It has a natural layer rifling to it. So you want to keep it from twisting under load as much as possible. So that will vastly reduce the amount of tension or torque rather on the cable when you're pulling. So there's tons of different types of swivels. There's sealed ones. There's even ones that you can purchase from we have a partner at PDi² that they have what's called a breakaway swivel that has a pin that will actually break if you have a maximum amount of allowable tension. So when that pin breaks, comes out the other side, you'll know if it's exceeded that tension, if the pin's broken in the swivel. If it hasn't exceeded that maximum tension. So that's more elementary.
Yeah. Is this something, is a swivel, is this kind of equipment the kind of thing that you would expect an engineer to specify, like in the plans and specifications for a project, or do you just expect a competent contractor to know how to apply swivels and when?
Well, I really like that question, Mike. I would say both. Man, if I was a standards engineer at a utility, or I'm, a standards engineer for one of the FANG companies who's doing data centers, I would probably have pretty specific requirements on swivels or duct mandrelling or using cable lubricant, specific types of pullers that need to be used. And I do see them in specifications from time to time. I will say pulling practices, I think, are becoming more dictated by engineers. And I think that's what your question is getting at, is we're starting to see a lot more requirements coming from engineers around this, because unfortunately there have been instances where people won't use a swivel. They don't use, X, Y, and Z in their pulling practices, and it causes massive failures. So yeah, I would expect, both hands to be a part of the process, but I think starting on the engineering side really sets the tone. I would highly encourage.
I have reached that conclusion in the course of my career, that it's incumbent upon the next generation of underground engineers to be very specific about the specifications, not to be redundant, but to have specifications that are very clear on the way this is going to be pulled. If we're going to get 4,000, 5,000 foot pulls, and we're going to maximize pulling tension, we're going to have swivels, we're going to have lubricants, and they all have to be properly applied. And I think it's the engineer's job to specify that and make sure, and then to enforce it in the field. And contractors catch on pretty quick, and they'll get it done, and they'll do it right.
I love the emphasis on proper application, because that's important too. It's one thing to have the tools there, but you need to use them properly, whether it's a consumable or it's a tool. it's useless unless it's done properly. And that's why I feel like factories or manufacturers are doing so much with their installation manuals and trainings now in the field to make sure that everybody is aware of what needs to be done to be successful in the field. So another one that folks might giggle at, but I will tell you it's so important, is pulling rope. People oftentimes, I think, balk at a pulling rope that in their mind might be more expensive than another. But I will tell you, getting a high quality pulling rope, or even having a high quality braided anti-twist aircraft cable on a diesel underground puller, all of that matters so much, because you don't want that rope to stretch over time. If it's a low stretch rope, it'll keep consistent tension on that cable or the conductor. If it's stretching, either it might snap or break, or you might have essentially some a galloping or jamming that may happen. And then also you want it to be smooth on the inside of the duct. I talk about this all the time with mandreling. I've never understood why an engineer would specify a wire brush mandrel. I'd love to hear in the comments why folks still love those wire brush mandrels. I want that conduit to be as smooth as possible on the inside. So having a rope that's nice and slick, which there's tons of different manufacturers that make them, it's so fabulous to have something like that in your conduit, because it's not going to braid the inside of the conduit then. All right. Another thing that I love to harp on, and this is really interesting. I was fascinated, Mike. One time, I won't name what cable manufacturer, but there's a lot of utilities that specify a specific brand, and I looked in their manual, and they actually disallow pulling grips at a certain tension, and that's because those grips actually pull on the outside of the cable on the jacketing rather than pulling on the
Right.
conductor. And if you've ever been on a cable pull and the cable comes out the other end after you've used a cable grip and it's under really high tension, sometimes that jacketing and even the insulation will be far ahead of where the conductor starts, which means you've really done a number on the insulation and the jacketing. So why would you use a pulling eye? Well, if you use a pulling eye, it's pulling on the strongest part of the conductor, or strongest part of the cable, which is the conductor. There are crimp-on ones. There's reusable power pulling eyes. There's tons of different types of pulling eyes. And what's awesome is most cable manufacturers will put them on for you at the factory, and critically, they will stagger them, almost like a multiple pulling harness, because you want one conductor after another coming through that sweep in a system, rather than having all of them bunched up, potentially jam inside of that sweep. So that's my mild amount of pontification on why you should use pulling eyes in that instance. So sidewall pressures, this is again where the pulling programs come in. You really want to avoid maximum sidewall pressure. All of this is dictated in standard specifications on the, or rather from the cable manufacturer. There's nothing more disappointing than being on a pull and somebody hasn't done the right calculation, and you see the cable come out, and you just see chunks that have come out of the side of sidewall, or rather the jacketing in the cable. So low friction conduits, cables, using swivels, using pulling lubricant, use everything that you can to reduce that overall coefficient of friction, which will reduce the sidewall pressure significantly. Same with
Hey, Matt.
increasing the bend rates. Yeah.
Yeah. So, what's your experience been when you've been in the field and you've seen the sidewall pressure get extremely high and actually damage the conduit? Have you seen then the utility inspector just flat out reject the pull, and they trash
Yeah.
the cable, and they have to go back and jackhammer out the concrete
Yep.
and replace the band?
Yeah, it's horrible. Or putting, I I will never forget. I'll keep the location of this neutral, but I sold a cable puller, and I was going out to this utility to do a demo, and I'd run the cable pull calcs ahead of time for what they said was the pull, and when I came, there were 3 more 90s in it than what I calculated it for. And they demanded that we still do the pull, and they were small radius 90s. And did the cable make it through? Yeah. Was it in good condition? Absolutely not. And it's just a matter of adding those small tips and tricks, or rather features in that can make a pull successful, reducing the amount of 90s or increasing the radius. But yeah, I've seen people have to jackhammer up a ton of concrete, or
Yeah.
I've also watched a PVC elbow burn right through the inside wall and pull the rope right through the dirt. I mean, it's horrible. So it's definitely
Well,
demoralizing.
we talk about the total life of the asset. We expect the life of a cable asset to be 40 or 50 years, or sometimes we're even talking about 100 years, which is pretty hard to think about. But that's with the expectation that a really well-written specification is followed, and that the cable is treated really well while it's pulled in. And then I like the idea of commissioning the cable before it's turned over to the owner as well. But
yes,
so
great
the points
idea.
are well taken here. Yeah.
Yeah. Well, and even, I mean, I'll take it a step further. We're so lucky now that we're beyond running line tensiometers or amp draw tensiometers on cable pullers. Now we have real-time data every second, pulling cable tensions down to I believe it's tens of pounds that can be recorded. Limits can be set on cable pullers so the pulling tension isn't exceeded. I mean, there's so many safeguards now that we have. But again, that's predicated on using the right type of tools. So,
hey, Matt, I'm just glancing at the questions from the audience, and your comment about a wire brush being used as for mandreling got some.
Oh yeah,
some reaction.
I would love to hear about this. Yes.
So you got an alternative to a wire brush that you like to recommend?
Gosh, I mean, I would say for cleaning out ducts, even using a slug style mandrel with PVC or HDPE discs, which are a little bit softer, is better than a wire brush mandrel. And with a slug like that, that's really going to take out most of the debris. You can also use a rubber swab or a rubber slug as well. But, I remember the first time I was at an underground training school put on by a manufacturer that I used to rep, who makes cable pullers, and we saw a wire brush mandrel go through a PVC duct system, and there were just little furls or curls of PVC everywhere. It's like, well, gosh, why would you ever want to use that? I mean, it's just eating up the inside of that duct, so just something that's smoother. I mean, there's still utilities. In fact, one you used to work for, Mike, that I believe specifies wood mandrels. And to be honest with you, I think a wood mandrel is perfectly fine because it's a softer material. It's just that wire brush that I really wouldn't ever use in a duct system if I didn't have to. So. All right, so we'll talk a little bit about what fiberglass does for us. So why are utilities, data centers, what have you, using fiberglass right now, and why does this dovetail into cable pulling and complex urban installations? Well, there's a few different things to think about. We've got an extremely low coefficient of friction, which is a part of reducing the overall pulling tension. If you look at our conduit versus PVC with a PVC jacketed cable, we're almost 70% less coefficient of friction than PVC when pulling dry. Certainly, cable pulling lubricant adds another factor on it, but it is reduced by a multiplier, so that ratio stays the same. So it's definitely something to think about, especially when you're in those sweeps. A very wise municipal superintendent once told me that pulling through a fiberglass 90 was like pulling through a PVC 45. It just reduces that overall tension so much. So heat dissipation, we get a lot of questions about that right now. So as a general rule of thumb, we have lower thermal resistivity than PVC or HDPE. So that means that the heat dissipates outward very, very efficiently, which therefore minimizes that buildup from those high current conductors. A lot of people will say to me, well, you really can only run cables up to 90C, and that's what PVC is rated at. So why are you guys rated up to 110C? It seems like more and more there are folks that are willing to exceed that margin or don't feel comfortable with running the cable wide open at 90C. They want to have a safety factor on that. So having something that supports a cooler operation will extend that cable insulation's life over time. There are so many factors, though, that go into that overall thermal performance and the ampacity advantage. So we're talking about things like, what's the conduit in? Is it in native soil? Is it in sand, regular slurry, highly compact concrete? All of those things, again, work in conjunction to either help or hinder that cable's lifespan or the rate of thermal or heat dissipation, rather. It's really no different than thinking about cable pulling. There's so many tools that we can use to either help or hinder ourselves with the initial installation, but we also need to think about, okay, how is that cable going to perform after that? And like you said, Mike, we really want this cable to perform for 40, 50, even maybe 100 years after that. So that lower temperature will increase the allowable cable ampacity. We work with numerous utilities right now that love using fiberglass conduit because they are not having to derate their cable as much. Same with the fact that fiberglass inherently has a thinner wall, but has the same OD as all IPS conduit that allows for a better cable fill rate between the heat calcs and then also the inside diameter of the conduit as well.
So Matt, you mentioned these utilities that you're working with. What specifically do they like to use fiberglass for? Do they use it for the 90-degree turns? Do they use it for under bridge applications? Or are they even going as far as saying, you know what, we're just going to use it in every application that we've got? Or maybe, let's say, on a critical infrastructure for a critical customer?
Yeah. So traditionally, and you know this from your background, Mike, we started with bridges early on. And then once people discovered that our 90s don't burn through when being pulled through, then folks started specifying those because they thought, well, I can use a fiberglass 90 that doesn't need to be taped, cold galved, all that jazz. It weighs a tenth of the weight of steel and it's a third of the price. And, has coefficient of friction that I believe is about 40 to 50% less than steel. Why wouldn't I use that? Well, now a lot of people have glammed onto the fact that we have a system that they can use below grade, whether it be concrete encased or direct buried, that you don't need to use adhesive with. And we're less than a third of the weight of PVC. We've got that same, low coefficient of friction that we have a lot of utilities now that are solely specifying fiberglass for their straight runs as well. One other tidbit that a lot of utilities clam onto is our conduit is actually fault resistant, and we've tested with a few different utilities and had real world faults on the inside. Super important if you want to reconduct or a conduit system, or let's say you've got packed duct banks. Do you really want to be chiseling up concrete or digging up a fault in the middle of the night? Or do you want to simply reconductor a cable run, pull out the old cable and pull in the new cable at the same time? Because we're not going to melt or weld to the inside of the conduit like you would with PVC or steel. So there's so many different.
That's a great idea. That's really hard to quantify, but that's a really great advantage. You went over that other example pretty fast. You said that there's no adhesives, and it's a lot lighter in weight than PVC. So it sounds like you might have some labor savings in there too.
Piles. Yeah. I will tell you point blank, if you go onto our website right now, we were fortunate to have, I believe they're the second or third largest electrical contractor in the United States, was willing to expose their labor savings with our product. They were doing a massive duct bank for a data center. This is when PVC went up, a crazy amount in price. 2021, 2022, when it went up 850% in price. They ended up purchasing our fiberglass where they didn't have to use adhesive, and they saved 63% on labor with our conduit over using Schedule 40. I mean, it's massive. And that's because a 20-foot long stick of our 4-inch conduit weighs 14 pounds. 20-foot long stick of PVC Schedule 40 weighs 48 pounds. So you can carry 80 feet of our conduit and it weighs 6 pounds more than 20 feet of PVC Schedule 40. So food for thought, especially knowing that we're in that crazy zone called the high 65 right now, which is the largest period of workforce exiting based on age in our country. So we got to start thinking about things that will be labor friendly, not fatigue our workers, keep them from being injured, and increase productivity when labor is, quite frankly, quite scarce. So I won't belabor this slide, more than it needs to be. There's Mike, you're probably familiar with SIME or the other calculators, right, that do heat modeling. I think there's probably multiple different ones that do it for electrical engineers. This is, again, where I'd say, hey, look at, what the RHO value is, whether it be soil, concrete, whatnot. Then you combine that with your cable and your conduit, really figure out what makes sense for you. So we'll nerd out for a tiny bit as far as how this relates to duct bank modeling. The long and the short of it is you really need to understand that fiberglass reduces that temperature rise compared to our other composite or plastic friends. We're really only using PVC, HDPE, or fiberglass in those duct banks. So you can use a glueless system like fiberglass, and then after the fact, rest easy that our conduit will actually dissipate heat faster than those two. I don't want to give an exact factor because, of course, there's probably a million different soil types or concrete types being used. But when you talk to folks who are doing hyperscale data centers right now, they're telling us that they're able to use concrete slurry over red dye concrete. And if that's reducing the concrete spend by anywhere from 60 to 80%, that's a huge, huge savings. So things that we can do as far as best practices go. Pre-inspect, your ducts like we were talking about. Definitely want to mandrel those, blow a mouse through, make sure they're clean. It's pretty simple. A lot more people, folks like yourself, Mike, are requiring that the ducts are scoped ahead of time. Is that necessary? I guess it would be up to the engineer, but at a minimum, they should be mandreled with a test mandrel to make sure that they're not out of round or nothing goofy has happened. We talked about monitoring the tension continuously. Again, there's so many different cable pullers out there on the market right now. Some are more advanced than others, and there are certain entities in this country that require real-time monitoring and require that to be given to them after the cable pull is done. I would recommend that anybody who's getting serious about cable pulling or heavy cable installation for utilities or data centers, it's probably time for you to either lease or buy or look into getting a more advanced cable puller that has those capabilities, because I think that requirement is going to be a lot more prevalent as time goes on. And then finally, use a compatible cable lubricant with that cable to minimize the friction, whether it be in fiberglass, PVC, steel, whatnot. That $70 or $80 pail of lubricant is such cheap insurance to make sure that your cable doesn't get damaged. There's plenty of different types now, and a lot of it is no longer messy or gloppy. You can either pour it in, spray it on. They've got bags that you can attach to the line as they pull it in. So it's very, very easy to use. So we'll do oh, go ahead.
Well, so I was going to advocate for cable lubrication as well, and I think that ought to be part of the specification. I think it's incumbent upon young engineers to put that into today's specifications for 2025. Okay, there's a couple of questions from the audience right now that I think you're getting ready to answer. One was, can it make field bends in fiberglass? And another one was, what is the OD and the ID comparison of fiberglass versus other types of conduits like you've got here? So maybe you're going to address that.
Yeah, so field bends, yes, you can. There's actually videos on our website of how you can do that. Fiberglass, the technical name for it is reinforced thermosetting resin conduit. So RTRC. Thermoset resin means that it's heated to cure, and then when it cools down, it stays in that static zone. So what you do with fiberglass is it's really combining the way that you would bend PVC and steel together. You're going to use a PVC hot box heated up to about 240 to 250 degrees, and then you're going to bend it over a regular steel bending shoe, preferably in a one-shot bender. So you need heat because, again, it's reinforced thermosetting resin conduit. And then, because it has the same OD as any iron pipe size conduit, you can use those same IPS bending shoes. You overbend it slightly, just like you would with steel, because it has a memory, a little bit of spring back. So overbend it by a couple degrees. And then if you're in a hotter area, or I'll say any area without snow, you just get a bucket with some water and rags and cool that conduit down until it's cool, and it'll stay in that static shape. Luckily, again, we dissipate heat quickly, so it does not take a ton of time for it to cool down. Or if you live in Minnesota like me, you can cool it down somewhat and then throw it in the snowbank. That's a joke, though. Definitely cool it down. So, and then the other question, IPS size, that's what we have for everything except for our extra heavy wall conduit. But really, 99% of what folks are using on the market have the same OD as like PVC or steel, but that ID is going to be larger by a factor of, our standard wall is 7/100 of an inch thick. I want to say scheduled 40 is, I don't know, probably 1/4 of an inch thick. So ratio wise, you're going to get a little more space in it, but looking at the cable fill charts, it'll be a noticeable increase as far as what you can fit into our conduit. So what do we need in the future? This is something that we spend a lot of time talking about at PDi². Is, we need more underground feeders. We need a lot more power. We also need to be thinking about how we're designing those duct banks to accommodate a lot more cabling, having utilities all communicate together on joint trenching, water, power, gas, sewer, all of those things commingling together. So it's really important that the utilities continue to work together, and hopefully joint trenching will continue to increase in popularity. Thermal management.
I love that idea. Have you seen that idea implemented? I know overseas in Sweden and France and some other countries in Western Europe, they do the joint trenching. But are you aware of anybody here domestically, Colorado Springs or others?
Yep. Yep, exactly, Mike. There's a few municipalities and some others that are either doing it or actively looking into it. But I think, it's 2025 now. I would say that within the next decade, from today, it's going to be far more prevalent because, again, everybody's using more resources, and it makes sense to have them, be clumped together. Um, Especially when really everything's going underground. So having those folks communicate, map, be aware of what's underground together is so important. It's, how do I say this? Equivalent, or it's the equivalent to me of the prevalence of BIM modeling in the commercial industrial side of our business. People are using BIM now so they don't have conflicts in the interstitial space of buildings. If you're running all these different
Right.
cables or conduit piping, you've got this beautiful modeling software now that can show how all of these different utilities in a business can commingle harmoniously together. So, and then finally,
So the building
obviously,
information model or the virtual twin is something that's definitely coming to underground in the years to come. I mean, it's really here right now if the utility wants to do it, but it's going to become much more mainstream. And let's just comment too quickly. You talked about the need for this, and we talked before we started about your plant capacity, and you told me that you guys have reached record backlog. So that would speak to the fact that a lot of people are understanding the value of fiberglass. And you guys, and I guess you've got competitors, I don't know, but you've got a large demand right now in the industry for what you do.
It's massive, and we foresee it growing exponentially. Luckily, we're doubling the size of our facility. First half of that will be completed by the end of this year. Next half will be, around early April. So we are making massive investment in our facility right now to respond to the increasing demand. I don't anticipate that will be our last expansion. I wouldn't doubt if we'll continue expanding for many, many years to come, because the secret's out on the thermal calc side of life. Folks are seeing the benefits from our heat dissipation and thermal conductivity, or rather thermal resistivity. They're seeing the benefits on the cable pulling side too. That low coefficient of friction is massive. And then finally, we make very large conduit. 8-inch is a massive seller of ours right now. And our 8-inch is super light and can be put together below grade without using any glue. And we're selling piles of it. And when you look at using us versus really any other conduit type, why would you want to use heavy conduit that's harder to pull cable through and doesn't dissipate heat quickly, when you can use something that's entirely American made, 100% BABA compliant, labor friendly, and cable friendly? We're really, really fortunate to sort of be that Goldilocks of conduit. Strong, corrosion resistant, but also lightweight, and has a low coefficient of friction. So,
yeah, great combination.
Yeah.
Okay, bring us home here. We're getting ready to wrap here.
Yeah. So it really, in the end, and this is the last side, is fiberglass supports that 40 to 50 year life cycle requirement. But in order to do that successfully, remember that pre-planning, like I talked about, having those right tools, right components. Use that planning to leverage yourself into a good installation that has the right materials to actually support good practices with cable pulling, and then good cable stewardship after the fact. And remember, this isn't going away. So, let's continue to think creatively about planning, materials, and then, really where we're putting that infrastructure after the fact. Hint, hint, it should be underground, so we can prevent damage. So with that, what can we answer for everybody?
Well, we've got some great questions in here, and we've answered, actually, Matt, as we've gone along. We've answered a few of them, but here's some other questions. So Looking at this one here. Okay, well, here's an interesting question. How many fiberglass conduit producers are there now in the market? That's a little unfair question, but I'm going to ask it anyway.
No, that's fine. There are 3, including us. So
Okay.
there's us and then 2 others. I will shameless plug here. We are the largest by a long shot, and we do only manufacture our materials, or excuse me, our product all in the United States, and our raw materials are all domestically sourced as well. So fully BABA compliant, family owned. It's truly a fabulous company to work for.
Yes, good. If record backlogs are the case right now, what are lead times like for fiberglass conduit, Matt?
Really good question. We're looking honestly, around that 20-week lead time right now. We'll see some very significant relief here coming into the spring. But what we keep telling our utility partners and our contractors is, despite this being conduit, and a lot of people think of conduit as a, how do I say this, a consumable or a commodity. We are a spec product. We're a product that offers so many distinct features and benefits that we have a lot of folks that are ordering their entire yearly use 6 months ahead of time, and have had 0 issues with lead times because they planned ahead. But they're saving piles on labor, and they also know that their cables are going to be safe for years to come in our system. But, again, going back to the fact that we're expanding rapidly, I would assume those lead times will go down considerably. But it all depends upon adoption too. So we'll keep expanding, but we certainly are advocating for our customers to plan ahead as much as possible.
Yeah. I'm going to ask you this question here about IEEE 1185. It's a specification for cables, but I want to give you a moment to think about that as I go to this other question from one of my favorite Tennessee municipal utilities. What's the best way to lubricate long duct bank lengths?
Oh, wow. Well, there's a couple different schools of thought on that. You could certainly, well, I'm an advocate for pre-lubrication. So definitely, get yourself a sponge, put, a pile of whatever cable lubricant you're using on that, preferably like a high performance silicone-based lubricant like Polywater.
Like American Polywater. American Polywater is one of the members of PDi².
Yep. Yeah, I'd fire that through the duct system, pre-lubricate it, and then as far as applying lubricant, if it was me, I'd definitely use either a pourable lubricant and pour that onto the cable as it's going into the duct system, or if you want to, there's these things called like front end packs that you can actually attach to the rope or the cable. They essentially just hang off of a clip, which is already on that plastic bag, and you actually just take a box cutter and slit them, and as they're being pulled through that duct system, they just squeeze the lubricant out, and that seems to work really well. But I'm an advocate of, spraying it on. You can pour it on or use those front packs, but definitely don't be chintzy with it because it reduces the tension considerably.
Okay, good. We're coming up to the top of the hour here. Somebody asked a question about price, Matt. And so what's the relative cost difference between PVC and fiberglass? And I'd say after an hour of having a conversation of all the value that fiberglass adds over PVC, it's just like, well, I'm not really comparing apples and apples. It's kind of like when we talk about overhead versus underground. We want to look at the total cost of ownership or the total cost of installation, not just whatever the front end cost is of a cable versus an overhead conductor. So I'll give you a moment to maybe comment on that, if you would. And then if you do have a comment on that specification, IEEE 1185, you can add that as well. We got about 5 minutes left here.
So as far as the cost goes, we're going to be uh, more expensive than PVC, but far less than steel. So again, in that sort of Goldilocks area. PVC fluctuates in price a ton as well as steel. I will tell you that we're quite price static. If you remember back earlier in the presentation where I said PVC went up 850% in price, we went up 16.5% in price in that same period. And that's because we're using epoxy resin and hardener. And PVC uses brominated and chlorinated resin, which also does mean that they have halogens in their product. Our product is inherently low smoke, zero halogen. So when it burns, it's not off-gassing toxic halogens into the air. That's actually why a lot of utilities have moved from PVC or UGuard over to our fiberglass, because we have a higher temperature rating than PVC, and we also don't off-gas bromine or chlorine when we're being burned as well. So, I don't mean to say that to skirt the question. It is more expensive on the purchase price than PVC and less than steel. But when we talk about total installed cost, most of the time folks are seeing savings when they're installing fiberglass, when you add those two together. So it's either cost competitive, or you might actually save money on the total cost when you combine installation and
on some of the quantifiable things like construction labor. That's definitely quantifiable. Safety is hard to quantify. Reliability is hard to quantify. Better thermal resistivity and ability to dissipate heat, that's hard to quantify, but these are all very tangible things that need to be considered, and their added benefits. And 5 years down the road, we may be able to quantify some of these things using some of this artificial intelligence that we're actually building the system for. Quick comment on the IEEE 1185. Is that a specification that you're familiar with and something that you'd recommend for engineers to look at?
Off the top of my head, I'm not, but I'm going to write that down. And whomever asked that, I'd ask that you send me your email, and I will respond to you. My email is on the next slide, so I'll put that up there so you can jot that down. And if you send me an email, I'll respond with the information that I have on that. I'll speak with my engineers. I want to make sure that I respond. So.
I appreciate that. So outstanding presentation, really timely, and I really appreciate, Matt Fredericks, what you and Champion Fiberglass are doing, and appreciate you guys being members of the Power Delivery Intelligence Initiative. Why don't you take a minute or so, Matt, and wrap it up and give us your concluding remarks as you send us off.
Yeah, absolutely. Well, again, thank you, everybody. If you have any questions at all, feel free to jot down my email. More than happy to either respond via email. You can call me. Otherwise, very, very happy to do an additional web meeting or fly to you in person. I think what I will say is, fiberglass conduit for a long time was pigeonholed into, bridges, or perhaps just using the sweeps. There's a lot of advantages to realize by using our conduit. And I'd really encourage folks to think about that pre-planning and how fiberglass can fit into that.
All right. Well, I appreciate you and your team being part of the Power Delivery Intelligence Initiative. And on behalf of all the members of PDi², thank you for listening in today. We appreciate it. We wish you a very happy holiday and Christmas season. And Jeff, I will hand it back to you for any concluding remarks.
Yeah, certainly. Thank you, Mike. That is all the time we have today. But for those questions of yours that we didn't have time to answer, we will be getting back to you on those via email. Thank you very much for sending them. Again, your questions are what make these so enlightening. So that concludes today's presentation. So on behalf of T&D World, I would like to thank Matt and Mike for today's presentation, and as well as thanking PDi² and Champion Fiberglass for helping us bring this webinar to you, and of course, all of you for joining. So thank you again, and I hope you have a great rest of your day.